Hello everyone. Well, work begins on the Philips 555A. If you've not seen what it looks like from the front, I suggest you look at my video I posted fairly recently that shows you the 470A and the 555A that I bought recently. Anyway, the chassis is out, which is a bit of a pig to get out, and I'll show you why in a minute. As you can see, the set has been worked on. If you refer back to the 470 and 558 video, I pointed out that these wet electrolytics here looked a bit dodgy, and in fact they've both spilt their innards out of the top there. There's one here and one here. I think both were 32 UF. Now what someone's done is they've replaced those, and you can see where the original wires would have gone. The capacitor's up there underneath. You can see it's you can see the nut holding it in. Someone's replaced these with 32 UF at 350 volts. They look fairly recent. I would say 60s or 70s capacitors. Obviously modern ones are you know, a third of that size. So what I'm going to do is reform them and see how that goes. I've actually reformed that one and it came up really well. You've seen it in my previous video. I think it was the Defiant radio. This is an electrolytic capacitor reformer. It sticks out 240 or about 320 volts over a very low current, and reforms these. Now I've got this is the output. There's going to be about 320 volts coming out of these two, well, that one actually, and I've got my voltmeter on my DMM set across the 100R resistor that's in there. So we're looking for about a milliamp of leakage per 10 UF at best. Let's switch it on. I'll switch my meter on. I've got it on the 2 volt scale there. So what we need to remember to do is times anything we see on here by 10. And that'll give us the milliamps in leakage. Now I'm not going to go near this. As I say, there's over 300 volts coming out of there. I'm not going to touch the chassis. I'm going to check every few minutes by switching off at the mains and checking these aren't getting warm. Obviously, if you've repaired valve radios a long time, you'll know all this, but just in case there's anyone new watching, please be very, very careful here. Remember, you've got the same voltage coming out of these, albeit at a low current, but it will still give you a nip, and I'm not going anywhere near that. So let's switch on. As you can see, the meter's dropping quite well. You know, it's, there we go, that's well under 0.3. Let's see how far it'll go down very quickly. The other one's about 0.07. So I think these electrolytics here are very, very usable. I'm not going to replace them. While we're doing that, let's have another look around the inside of the chassis. As you can see, it's got the Philips tar covered capacitors there. If you can just see one just here, look, this is quite a hard sort of tarry wax. Is there a better view of one there? Look, just above the normal sort of brown wax capacitor, you can just see one. It's a shame really, because I would like to restuff this and make it as if it's original underneath, but these are really hard to restuff just because of their shape. I think this one's an electrolytic. That must be the cathode bypass for the output valve. And there's another tar capacitor up here, look, Philips, in its insulated paper jacket. It must be just to hold it steady. Don't know why they've done that. There's another one. Oh, that looks fun to get at, right at the back there. There's another sort of bomb shaped one down the bottom here. But yeah, it's not been worked on too much, so I'm thinking that this should be pretty easy to fix, and it was probably working before it went up in someone's loft. What there is to do before I even get power anywhere near it, or mains power, is all the transformer wiring. It's all mouldy, so all this upper wiring, all this, because it's starting to go here, it's very hard, it's going to have to come off, so I'm going to have to rewire pretty much the whole set. And even inside you can see there's this, particularly the yellow it seems, has crumbled. That's not good. So I'm going to have to rewire all this. Quite interesting to see in these Philips sets is this the coil method. So even in production, not just to repair, they've used these little coils here to join lengths of wire. Hopefully the camera's in focus there. Yeah, can you see those little coils of wire? So as I say, not just for repair, Philips used them when they made sets. Right, let's have a look where we're at with the reforming. Well, we're well down. I think that capacitor's perfectly safe to use. I'm going to switch off before we start poking around in the set anymore. There you watch it discharging. If you want to have a look at this capacitor reformer, and I'm going to rebuild this and put a meter movement in there, because it's not, it was one of my first projects and it's not the greatest build. If you want to look at this, if you click on the UK Vintage Repair and Restoration Forum on the web, you'll find the instructions for building it. In fact, if I swing round, I'll show you the page. Right, there's the page there, high voltage electrolytic capacitor reformer, and you can see that there's the address for it. It gives you all the instructions for building it, and on Vera board, and also there's a 120 volt version for our friends in the US there. This is a version that someone's built with 2 meter movements on it. If anyone wants to know more, please just PM me and I'll send you the link if it's not visible on the video. Right, so we're gonna unplug the reformer. Right, now getting back to where we started, the removal of the chassis from this set was a bit piggish, and anyone who's ever worked on Philips sets will know they came up with some actually really quite mad ideas. This is the dial pointer behind here, and it's on a spring. So I've released the screw here, so but there's actually like a tension spring. I just can't work out why they've done that. It would have been so much easier just to do it another way. This is the wave change, the wave band indicator here. But why do that? I don't know. It's like a clock spring in that box there. Really odd. And if I show you the front of the chassis here, right, this bit of wire comes up. You see, I don't know if you can see it. This bit of looped wire, typical Philips fashion, comes up around that and then round that spring thing there where it locks into a little hook on the side. It's just just mad. And that's fairly normal to see a wire for the waveband indicator, but yeah, just absolutely why did you do that? This is the push button unit, and to turn it onto manual tuning you pull the tuning knob out like that, and that disconnects. You can manually tune then. That disconnects the push button unit. Let's have a look at it. I'm not going to tune it because I'm not sure that I can get it back into the same position, but obviously that's the tune. It's what I'm going to do in a minute after I finish this video, is put the set back in there just to make sure that I can all fit it back together again. Then obviously I'll get it out and start replacing some of this wiring. But yeah, very interesting to see the inside of sets and compare how different manufacturers made them. There's a tone control on the side there. And you got obviously your volume control, wave band, and your tuning. And inside there's the speaker, and that I'm going to have to unsolder that to remove the chassis completely. And it's got a huge great one of these tar capacitors on here. It's probably a tone correction. It sits across the output transformer down there. So that'll need to be replaced with a 1 kilovolt capacitor really. And up here, that's where the tuning or the magic eye sits, in that bracket there. Right, so I think the next time I do a video I'm going to have all this wire replaced, and we can have a look at applying some power. There's my Selena that featured in a recent video. I've polished the cabinet actually and repaired it, so it's all looking better. This is the AZ1 rectifier valve out of this Philips 555A, and it was very loose in its base, so I've put some French polish in between the envelope and the base there, and hopefully that will set, and the valve envelope won't wobble around anymore. Right, I hope you've had a good look at this set. There's this cushion that sits over here. There should be 2 springs that were missing actually, I understand, that sat sort of in between this bit and the knob and held it tight to the case, because it doesn't fix any other way. So I'll have to find a spring, a couple of springs or something that will sit behind these knobs. I've managed to get a circuit diagram for it. This is the wireless and electrical trader version, and as you can see, this set here was released in November 1938, and as we stopped producing sets here in the UK in about 1940 due to the Second World War, this one's definitely 1938 to 1939, I would imagine. I'll see if I can find any dates when I start pulling components out. But anyway, it's going to keep me out of my partner's hair for a few weeks, I would imagine, and I'm sure she'll be most happy about that. Well, thanks for watching, and hopefully I'll be back soon with another video.